All right, here's a review on how to do the CERs for thinking about boiling point. So first of all, the background information you make sure you need to understand is that when something boils, all right, what happens when something boils is the intermolecular forces need to be broken. All right, the only way you can do that is to pull the particles away from each other. All right, remember that intermolecular force is an attraction, and so you need to overcome the attraction. Or they're not necessarily you, but the particles. So they're stuck together. Kind of think about magnets. Like the best way I can tell you to think about particles is like magnets. Okay, the stronger the intermolecular forces, the stronger the magnets. So when they're stuck together, that's a liquid or a solid, and then in order to become a gas, they have to be separated. So the question becomes, which of these two molecules, the one that's going to have the higher boiling point will be the one that needs more energy to overcome those attractions. Remember, energy and temperature are correlated to each other. So I'm just going to label these A and B for simplicity. Okay, so I always start with the evidence first, and I think that's a good thing to do. So you're looking at your intermolecular forces, and you need to identify there will be some sort of difference between them. In this case, B has hydrogen bonding and A does not. So that's what I'm going to say. So B has hydrogen bonding, A does not. I'm not making any judgment about it. I'm just making the observation that that is what I'm seeing. So there'll always be some sort of difference between the two. Okay, then the reasoning next. All right, so then you have to say, okay, well, why does this matter? And how does it connect to the boiling point? Okay, so the reason it matters is because B has stronger intermolecular forces. So now I'm making a judgment, or stronger intermolecular, stronger IMFs. All right, so that is what that evidence tells me. So it takes more energy to separate the particles or overcome the attractions. Okay, so then from there, now that I know which one takes more energy, because remember, energy, we're talking about temperature. Temperature is our measure of kinetic energy. So if it takes more energy, that would lead to the claim that B has a higher boiling point. All right, so again, start with the evidence. You're just stating what you see with the intermolecular forces. And then in the second one, you're going to say why that matters. So B, since hydrogen bonding is stronger, it is B has stronger intermolecular forces, so it takes more energy to separate the particles. So again, we're looking for this statement about which one is stronger. We need the statement about the energy, and then you need to tell us what's going on, like what is that energy doing? All right, let's try another one. Okay, all right, so this one. Now, again, look at the intermolecular forces, and that's where we're going to start. Again, I'm going to label these A and B. All right, so they both only have LDF, but there's a difference in them. So my evidence is that B, or I'm going to say actually both, have only LDF. B has more electrons. Okay, so the only time the number of electrons matters is if they have the exact same forces. In this case, they do, so I have to go to the electrons. Okay, so then my reasoning. So now I have to figure out what that means. Well, what it means is B, since B has more electrons, it has stronger IMFs. So there's a stronger attraction between the particles of ethane, or letter B. So it takes more energy to separate the particles or break the attractions, something along those lines. All right, just make sure that you are not The thing that will negate this whole answer is if you start talking about bonds. All right, you start talking about bonds, and then you're showing us that you don't understand what it means when something boils. All right, this is a bond. When something boils, that does not break. What happens though is that instead of having these two, I'm just going to label this B, these two particles stuck together, what happens is they separate away from each other. All right, all those bonds stay in place. You need a lot more energy to break those bonds because, again, bonds are stronger than intermolecular forces. Okay, so then my claim, so since B has stronger intermolecular forces, that means that B has a higher boiling point. All right, and there you go.